Okay, this is actually the second part of Notes 4-7 and then Notes 4-8. So on number 10, since it tells us that our shape is, our height is 8 and then our similar box is 6, because it says it's similar, we know both of our dimensions are changing. But we're going to want to set up a proportion on this one. We know our scale factor is 8 to 6, which we would want to change to 4 to 3. So we're dealing with our large shape and our small shape. Our scale factor is 8 to 6, which is 4 to 3. We're going to want to change that. Because we are dealing with area and it's similar and we know both of our dimensions are changing, then this is dealing with both dimensions. Both dimensions are that. And so then we're talking about a surface area of 384 for the large over x. So then, of course, whenever you solve this, you're going to do 16 over 9 equaling 384 over x and solve from there. So with number 11, when we know that it comes right out and it tells us that it's a fourth, it says our dimensions is a fourth. It's not like it's saying the ratio is 8 and one of the heights is 6. It says that the small one is a fourth of the large one, and we know the large one. So our new is going to be our old times this change. Now you could set this up like a proportion because there's only one dimension. We only have one dimension of change. Our large one is 284, and our dimension of change is 1/4. And so that's how we get our new circumference. The other way you could do this if you want to, same thing, is proportions. Our small and our large. And we know that the ratio is 1 to 4. Of course, that's only happening once because we're only talking one dimension of change in circumference. And x over 284. So either one of those ways is a way to do that problem. Since it comes right out and it tells us it's a fourth of the whatever, then we can do this way over here. Okay, and then our number 12. Our rectangle has a width of 9 and a perimeter of 48. So that's interesting. We know that the width is 9 and we know that its perimeter is 48. But when it talks about the second shape, it talks about a length of 10. So I need to know what this length is. I know its width is 9. So I'm going to figure out that this is 9 over here. That makes 18. 48 minus 18 is 30. So each one of these lengths has got to be 15. Okay, so then I'm going to go ahead and set this up. I know I've got my large to my small. I can tell my larger one was 15. My smaller one is the 10. This one had a perimeter of 48. Of course, this is just to the 1 because it is a scale factor of 1. And 48, and we don't know this new perimeter. Of course, you would want to reduce this scale factor before you go doing all your solving. I think it will come out the same. It's just, probably more proper to, think of those things in reduced terms, and so then you can solve that. Okay, but now what I want to do is actually go to the notes on volume dimension changes, and I think I left that first page off of what you have copied, but you can see that with volume, since we're dealing in 3 dimensions, that you have a situation where your scale factor is being affected 3 times. So let's take a look at this number 5. Again, like that one 2 problems ago on number 11, where it said the glass tabletop was a fourth of the radius of the large, this one is telling me that all their dimensions are changed to a third of the original. So I could do this way that I like doing this. New is original times your change. Well, we are talking volume. All the dimensions are changing: the length, the width, and the height. So I'm having 3 dimensions of change, and my original was 135. So I would multiply 135 times a third times a third times a third, and that's how I would come out with my answer. And on number 6, you could do this, but it gets difficult with the way it's worded. It doesn't come right out and say it's a third of their original size. It doesn't set that scale factor there. It tells you one's 15 and one's 6. Well, is that 15 sixths or is that 6/15ths? So since you don't really know necessarily, you could figure that out, which way you're headed. I recommend proportions on problems like number 6. So we need to keep straight which is our large and which is our small. Well, I can obviously tell 15 is large and 6 is small, and that 375 corresponds with the large, and I didn't need to know that small volume. But please keep in mind, since they are similar, all three dimensions are changing. All three dimensions are changing. So this 15/6 is occurring 3 times. So I would then, of course, want to reduce that by 3 and have 5/2 occurring 3 times because it's volume. All three dimensions are changing. And so that would set up 125 over 8 equaling 375 over x, and then you can solve that. Okay, and so I really like 7 and 8 the best. 7 and 8 to me are most like the tax problems that I am starting to see, especially on the '06 test. Because not all the dimensions change. So even though we are talking volume, and we have a cone here, so we have 1/3 big B times h, which our big B is pi r squared. This says the radius is increased by a scale factor of 2, but the height stays the same. Only the radius is changing. So only the radius is doubling. And how many radiuses occur? How many radii are occurring in this shape? 2. So we know that we're going to multiply by 2 and multiply by 2 for each radius of change. So therefore, what effect is happening to the volume? It's this times 2 times 2. So the volume of the new is times 2, which is quadrupled. And then number 8 is good in pointing out, well, what would happen if we had the same situation, 1/3 pi r squared h, but only the height is affected. So only our height is times 2. So that dimension of change is only occurring once. So the volume of our new is doubled because only, even though it's talking about volume, only one dimension was affected.